Okay. So what we're going to do is start first. Remember yesterday we left off with the problem? We were on concept or the third scenario when we looked at solving radical equations for concept 7. I want to do one more of those, and then we're going to learn some factoring techniques. So the stuff that we learned today is not going to be a new concept. So when you get back on Tuesday from work, your assessment will only be on concept 7. On concept 7. But I'll tell you right now, it's going to be scenario 3, which is the more difficult of them, okay? So we're going to go through an example of that right now, then we'll go into a factoring technique. The reason we're going to be doing this factoring technique is because throughout the year, we're going to be using it. Okay, we're going to be using it, especially when we get to quadratics. And it's important that everybody understands how to do this. So first, let's start with concept 7, and we'll write continued. Again, because we're continuing from yesterday. So if we have a problem like this, let's say we have radical 2x plus 2 equal, let's see, x minus 3. This might be the same one I did earlier. I don't know if it was or not. And we want to solve this equation. We think back. Concept 7 tells us to isolate the radical as step 1. From yesterday, isolate the radical as step 1. Well, the radical is already isolated. What was step 2 telling us yesterday?
Oh.
Good. Raise each side to the second power or raise it to the corresponding exponent. So here, when we do this, please make sure you put those parentheses in. If you do not, it won't remind you that you have to FOIL on the right side. So on the left-hand side, the square and the square root cancel, and you're left with 2x plus 2. But on the right-hand side, we must remember that when you square a binomial, it's like multiplying it by itself. So we have to FOIL or box method. Okay, your assessment today, you didn't actually have to do this. Okay, because today there was no binomial on the right side, it was just a number. So when you squared both sides, you just squared a number. But now we have this binomial here, and when we square it, we have to think of it as multiplying by itself.
So that's going to be on the quiz?
So this kind of problem is going to be your quiz on Tuesday, yep? The one that we're doing now. Obviously different numbers and stuff, but the same type of problem. Now if we continue, does anybody want to see box method? I know we all know how to FOIL. Have you ever seen box method before?
Yeah.
Too much.
Too much?
Yeah.
It's too much. So let's do this. On your own FOIL, tell me what you get. I'm going to show box method, you don't have to use it. But I'm just going to show it on the video so we can see. So if you FOIL, you should get the same thing that's right here. And again, this is really negative 3x and another negative 3x, which makes it negative 6x, which comes from these two values right here. So your middle terms, your O and your I from FOIL, will be a negative 3x and another negative 3x, yielding negative 6x. Eduardo?
Why is it negative 6?
Why is it negative 6? Because we've got a negative 3 here. When we multiply that by the inner part, you're going to get negative 3x. We have a negative 3 here. When you multiply that on the outer, you're going to get negative 3x. Negative 3 and negative 3 gives us negative 6. If it was negative 3 and positive 3, that's when they cancel. Okay, again, when you do the outer, you're going to get negative 3x, and when you do the inner, you're going to get negative 3x.
Oh, okay. I was thinking about multiplication, that's why.
Because this is negative 3 here, times x is negative 3x. This is negative 3 times x is another negative 3x, giving you negative 6x. Okay, now, at this point in time, we've got to do what? How do I solve the resulting equation that we have?
And the factor.
Okay, before I can factor, because if I factor now, I'm going to get back to the last step.
Okay, to do minus
combine like
2.
terms.
Good, combine like terms or get a, what did Andy say?
Zero.
Good, get a 0 on that left side. Now, it does not really matter which side we make equal to 0, but if we move the x squared over, it's going to become negative x squared. So we don't want to move the x squared over. So let's move the 2x over, and then we'll move the 2 over. So here we're going to get 2 equals x squared minus 8x plus 9. Again, we're moving the 2x over first. Then we'll move the 2 over. We're going to get 0 equals x squared minus 8x plus 7. Again, the whole goal of this process right here is to get 0 on one side of the equation. And when we do this when we're looking at quadratics. We have a quadratic here, we got to get a 0 on one side. Now, the next thing we have to do is to learn how to factor, like Melissa said. This, in this case, actually is a simple factoring one. We're going to go on to look at a more difficult factoring technique in a minute. Let's go to the next page. We had 0 equals x squared 7. Thank you. Thank you. Okay. Now, looking at this one, can somebody factor this for us right away?
Alright, so I'm going to do that. The first column for that one.
Okay.
Can you try to?
You don't need fractions and decimals. Later, oh, it doesn't matter later on. You wait whatever you like. But what are the numbers that are going to go here? That's my question. You want to go? I'm going to go over how to do this?
Yeah.
Let's do this real quick. First, look at your value of C. C is equivalent to 7. Look at your value of B. Your value of, I apologize. Your value of B does not include the X part. Your value of B is negative 8. Now the question becomes this. What numbers multiply to give me C and add up to B? What numbers multiply to give me C and add up to B? They got to multiply to give me C. It's either 7 and 1 and 1 and 7, right?
Yeah.
How do we know we can do this? The easiest way to do it is to always just list the factors of C. So you can start listing the factors. This one is easy because there's only one possible answer here. You're going to get either 1 and 7 or negative 1 and negative 7. Again, what are the factors of 7? Either 1 and 7 or negative 1 and negative 7. Which of those adds up to negative 8?
Negative 1 and 7.
Negative 1, negative 7. We need a negative, guys. We're looking to get a negative 8 here. So we need these signs to be negative and that negative there. So we're going to have minus 1, minus 7. Again, what numbers add up to B? And be careful with the negative sign there. Now the last step. Let's talk about this for a second. Here. How do we know what to do next? And I know a lot of you know what to do, but how do we know what to do is the question. Let me give you a little.
I remember you have to check. You have to check. I mean, x equals negative. I don't know how to explain it. X equals negative 1 and x is negative 7. There's 2 x's. Then after that, you have to check both of them to see which one's correct.
Okay, you're in the right process, absolutely, but the numbers were a little off.
X is 1, and the other X is 7.
Okay, how come?
1 minus 1 is 0, and 7 minus 7 is 0.
Very good, good way of thinking about it. Looking at this problem, what do we have here? We've got one thing multiplied by another thing, and together they give us 0. So, think logically for a second. 0 times 5 is 0. 5 times 0 is 0. Does it matter which of these two is 0? So this value could be 0, or this value could be 0. So what we must do is try to set each of them equal to 0. So we say, okay, well, x minus 1 equals 0, or x minus 7 equals 0. And we make a t-chart here. Now at this point, as Anthony said, we're going to get 7 here, and we're going to get a 1 here. So clearly we could have just switched the signs, because these binomials do only have a 1 as a coefficient here. When that changes, things are going to change. So make sure you understand what we're doing here. We're setting each factor equal to 0. Again, if you want to write a little note for yourself, we are setting each factor equal to 0. Now, as Anthony said a minute ago, or as Melissa said, sorry, a minute ago, we have to check our answer. We have to check our answer. First of all, let's discuss what we know about polynomials. When you see x squared up here, what does that indicate? 2. Anybody remember? What is it?
2 X's.
2 x's or 2 answers or 2 solutions. When you see x squared, it means you get 2 solutions, which is what we have. But go back to the original equation. Look at the original right here. Forget the squares because they were not there. Are there any x squareds in the original equation?
No.
It's only x to the first power here, right? So if you have something like x to the first power, it means there's really only going to be one answer. Well, if there's really only one answer and we got 2, what does that mean? We got to check both, right? Because one of them is wrong, or one of them is extraneous, we'll talk about in a second. One of them we will reject as a solution. So let's continue here. So if we look at, let's take our original equation, root 2x plus 2 and x minus 3. Root 2x plus 2 equals x minus 3. And we're going to check x equals 7. And we're going to check x equals 1. Those were our 2 answers, correct? What do I do with those values?
Put 7 in all X's.
Good. Just put the 7 in all the x's, then put the 1 in all the x's. So here, I'm going to use different colors so you can see. So here's where my 7 goes right here, and here's where my 7 goes right there. Again, I put the original equation there. I don't put the x's in. I put a 7 into the x. On this side, it's going to look similar. Here's going to be my 1. There's going to be my 1. Now, I can continue the process and see what I get. On this side, 2 times 7 plus 2 is?
16.
So we got radical 16 equals 7 minus 3. What's radical 16?
4.
7 minus 3? So that one works out.
That's what we want.
So we already can tell that the other one is going to be extraneous or wrong in a sense. Let's go through why. 2 by 1 is 2, plus 2 is 4, so we got root 4 equals negative 2. Now, when you take the square root of a number, it really has 2 answers, positive or negative, plus or minus 2. When you check these answers, we are only looking at the positive root. So if you need to write that down, write that note. We're only looking at the positive root. And this will say 2 equals negative 2, which is not true. So we reject this answer. Again, we accept this one over here. Here we're going to say reject. Reject the extraneous solution. Okay, we are going to reject the extraneous solution. What does extraneous mean? What does extra mean? Leftover, something that you don't need, right? Extraneous means the other solution that really didn't count for us. It's an extra solution that actually does not fit the case. It is like an apparent solution, okay? But again, we reject it, meaning it is not the answer. So the answer that we're going to finish with in the end is x equals 7. X does not equal 1. Okay, again, the process is the same no matter what you're looking at. So whether or not you're looking at, let's say, something similar to this, but with a 3 instead of the 2s, or with a 4, same process. You're going to get 2 answers. You're going to have to check them both. One of them will most likely work. One of them will most likely not work. In this case, it's always going to be 1 and 1. If the problem changes up a little bit, then it's going to change up the method. Questions on this? How are we doing? Can we wait? No, it's in the neck. The next thing I want to do is extremely important that you pay attention here, because throughout the year we're going to use this over and over and over again. Okay, we're going to use it when we do quadratics. We're going to use it when we do polynomials. We're even going to use it with trig functions. It's going to keep occurring. And next year in pre-calc, the same exact thing. So the next thing we're going to do is going to be called AC method. Okay? The next thing we're going to do is called AC method. And there's a reason why it's called AC, and I'll explain that. There are a lot of steps here, so please do your best to stay with me on this problem. Let's look at an example of, let me come over the door for you. Okay, let's try this one. Given this quadratic, we are going to need to try and factor it. But it's difficult to factor because of that 6. So right away we think, okay, this could be something with a 6x and an x, or it could be a 2x and a 3x. It could be any of those. But we don't want to sit here and guess and check numbers. So we're going to learn a technique that solves these problems every time. The technique is called the AC method, because we're going to be using our value of A along with our value of C. Okay, that's why it's called the AC method. So here, the first thing I would like you to do, list what A times C is equal to. So first write down AC equals, and A is what?
6x squared.
Be careful, A is just 6. Again, A is just the coefficient. 6 times negative 12. What do we get from that? What's 6 times negative 12?
6 times negative 12, negative
72.
Negative 72. Now, after that, list the value of B. What is the value of B in this case?
Nothing. Nothing.
What is it? Thank you, Kelly. It is 1. There's an imaginary 1 right here in front of this x. So B is 1. Now, that's your starting point. Next, if you go back to what we did before, we listed the factors of C. Earlier in this program, or in this lesson, we listed these factors of C, and then we said which one of them add up to B. Well, we're going to do the same thing again, but now we're going to list the factors of AC and see which ones add up to B. So we have to sit here and list all the factors of negative 72. Okay, it's going to take us a little while, but let's do it.
Negative 9 and 8.
Okay, negative 9 and 8, or
36.
hold on, or 9 and negative 8. To do both.
32.
Which one is which?
32. Negative 2. Negative 2. And then 2.
Okay, somebody else, give me another one. What else we got for 72?
2 and 1.
72 and 1, very good. We'll do one of them negative, obviously. Okay, what else?
All 6 and 12.
6 and 12, clearly, because that was the ones that we had in the beginning. So we also got 6 and negative 12, or negative 6 and 12. Anything else? I feel like there's a 3 that works also, guys.
Yeah, because 7 plus 2 is 9. So 3,
You're doing the trick, right?
yeah.
Nice.
24.
Good. 3 times 24 is another option. So those are all of our factors of AC. There's a lot of them there. Which one adds up to give you 1?
Oh, yeah, 9 and 8.
What is it?
9 and 8.
Which one now?
Negative
9 and 8.
9
9 and negative 8.
Okay. Out of all of these values, this is the only thing that adds up to give me the B value of 1 that I need. Again, 9 plus negative 8 is the only thing that gives me this 1 over here. All the rest of these do not add up to 1. Again, all the rest do not add up to 1. Now, from that point, we have to now write another equation, and I'm going to explain this. So what I want you to do is go back to your original equation up here, and wherever you have a B value, like this, replace it with a 9 and a negative 8, so that your equation now looks like this. 6x squared plus 9x minus 8x minus 12. Again, if you want me to point out, what you'll notice is that this value right here is really just 1x, right? Which is what we had up here, 1x. So we're just breaking up the 1x into the factors that we chose as our answer. So all we're doing is taking this, we're replacing it with the 9 and the negative 8 here.
Excuse the interruption. On the route, come to the office, please.
So how did you get 9,
The office.
negative, and negative 8 to fit into that equation?
Because 9 plus negative 8 gives me 1. None of these, if you try adding all of these up, you're going to get negative 1, 1, 34, negative 34, if you keep adding them. The only one that adds up to 1 is 9 and negative 8. That's why I chose those. Okay, good question. Now, at this point in time, we got one more step to do here. Imagine, if you will, that there's a dashed line here that separates the first two terms and the last two terms. Again, put a dashed line that separates the first two terms and the second two terms. Looking at the first two terms, what is my GCF?
Greatest common factor.
Greatest common factor. What is it of these first two terms? So looking at these two together, what is it? 3 what? 3x. Very good. Be careful. So it is 3x. Factor that out and write what remains over. So we'll have a 2x plus 3. How do I know it's 2x plus 3? If I distribute this back out, I'll get back up here. Again, how do I get this 2x plus 3 over here? If I take my 6x squared and divide it by 3x, I get back to 2x. So think of this like dividing by 3x, and think of this as dividing by 3x. You see what I'm doing? 9x over 3x is back to 3. 6x squared over 3x is back to 2x. So if you ever don't know what to put in parentheses, just divide whatever you had by the GCF. If you divide it in this spot and in this spot, you'll get that number there. You're not actually going to do it, but you want to be doing that in your mind. Now, in the second part, I want to factor out a GCF. But I'll tell you one thing. My goal is to get this parentheses again. So I want this parentheses again to be 2x plus 3. What can I take out of here that will leave me with 2x plus 3? 4. Be careful. You're right, 4, but it's negative 4. Again, we need a negative here because negative 4 times 2 would give me the negative 8. Negative 4 times 3 would give me this negative 12. Again, the goal right now is for these two things to be the same. If they are not, there must have been a mistake along the way. The goal is to have the same things inside of my parentheses. Those binomials want to be the same. Now, the last step, Ron. The last step is just to put my terms together. By the way, this is called grouping technique. So what we're going to do here is list whatever the coefficients are. So we have one coefficient here, and we have another one over here. Put them together. 3x minus 4. That's one of your factors. And your other factor will be just one of the two that has already repeated itself. Okay. The 3x is on the outside. The negative 4 is here. If I take the 3x and a negative 4, that makes 3x minus 4. This 2x plus 3 and 2x plus 3 just carries down. And if you FOIL this out, or if you box method this answer out, you better get back to the original one, and you will. Okay, if you were to box method this or FOIL the final answer, you will get back to the original equation that we started with.
But then we find x.
Again, if we were looking for x, then we'd have to make the t-chart, set them equal to 0, and solve. All we're doing right now, though, is factoring. We're not even solving for x.
This is just for that problem.
This is all for this original problem right here. Okay, again, we could have sat here and guessed and take a look. 3 and 2 turned out we would have used this one. But I don't want to sit there and guess numbers all day. So we use this technique so that we can get the answer correct every time. And the more you practice, this is going to take you 30 seconds in the future. It took us about 5 or 10 minutes because it's the first time. But as you do it more, you can do this much faster. Kelly, then.
You know how, like, okay, you divide the 6 and the 9 by 3x?
Same thing over here. You're dividing by negative 4 here.
Yeah, but, like, how come, so, like, the x doesn't carry down for, like, the second number?
Where, right here?
Like, yeah, like, c versus 9x, like...
Because 9x and 3x, the x is canceled.
Oh, okay.
And then one of these x's cancels with one of those x's.
Okay.
Okay?
How did you get 3x minus 4 and 2x plus 3?
Right here?
Yeah.
I took the first coefficient of 3x right here. I took the second coefficient of minus 4, and I put them together. Then I took this one, which is repeated, and I only wrote it once. So this is your first factor. This is your second factor. Again, your final answer has got to go back into the beginning. So if you want to check your answer, what do? You just FOIL it out. That's it. FOIL out the final answer, and then you're good. Let's do another one together. Let's try a more difficult one.
Man,
refuse to talk about it. Okay, so you're right.
Sorry, Dan, what's up?
Mr.
When I
Tom.
get contact, I want a lot of things that I like. And then so we do this next week. No point. And then then I could do that. They will watch now. Okay, it's over now. And it wasn't over, it was kind of being out there. You didn't believe it, and you were like,
Okay, next one. Now, are you gonna wanna sit here and try and figure this out? No, you're not.
deleted my camera.
So let's use AC method again. First step, list AC. What is A times C right here? What is it?
That's why I was wondering.
Negative, it's 120, right? AC is negative 120 because A is 10 and C is negative 12. The value of B, well, let's put B in. Put B right here. B is just 16. Again, where does that come from? That's the 16 right there. So we start by listing our values. Now, this is tough because we got to list all the factors of negative 120.
10 negative 12.
Okay, so let's start. 10, negative 12, or negative 10 and 12. Now, let me stop you for 1 second. As you're going through this process, if you find the answer, stop. For example, 10 and negative 12 and negative 10 and 12 do not add up to 16. So these are not going to be the answer. But if you come across a factor you think is the answer, check it and then just stop. You don't need to do this all day long.
3 and 40.
30 and what?
3 and 40.
3 and 40?
It's not going to be.
Or negative 3 and 40?
4 and
30?
4, 30, yeah.
Or negative 4 and 30? Are any of these correct so far?
No.
None of those are going to add up to negative 16. Or,
No,
sorry,
negative-
positive 16. Thank you, Melissa.
It's 22 and 5.
What is it?
22 and 5.
22 and 5.
21 and 5.
We're trying to get, what are we trying to get here, guys?
16. That's 21 and 5.
Oh, I understand, but we're trying to multiply to get negative 120, right?
So negative,
21 and 5.
yeah.
Oh, 26.
21 and 5 is 105.
Oh, 26.
26 is another one.
I did you said 20.
Let's list more. We got 20 and negative 6,
Yeah, that.
or negative 20 and 6. That's close, but that doesn't work, actually.
Really?
What do they add up to? Don't they add up to 14 and negative 14?
Oh, yeah, 16. Oh,
What about
okay.
16? Okay, 5 and what?
57 and 8.
5 goes with what number here, guys?
5 and 26.
24.
24.
5 and negative 24, or negative 5 and 24. Do those work?
No.
What about 8? Nobody's
I
using
just
8.
said that 57 and 8.
What do you got?
57 and 8.
57?
No, wait, hold on.
Yeah. 1 and 8 gives me 120.
I have 20.
16.
What is it?
16?
16 times 8 gives you 120?
15.
I'm not thinking.
15.
15 times 8.
Okay, 15.
The calculator gave me the wrong answer.
Uh-huh. Or you type it in wrong.
That's why I don't like using calculator.
I agree. You gotta use it properly, right? We're still not there, are we? What else? What
I
else?
don't want to remember that. Oh, that's not going to equal it though.
We didn't try 2 yet. What about 2 and negative 60? Or negative 2 and 60? Does that work?
Run in circles.
That one doesn't work either. So we used 2, we used 3, we used 4, we used 5. Did we use 6 yet?
That's me 20.
12 and
6 and
6.
20.
We used 6 actually. It's right here, right?
6 and 22.
7?
Did we use 7? Does 7 work?
No.
7 and 12, 25.
How about 10?
7.
Or 12?
We used 10 already?
12?
We already used
We used 10. We used 12.
7, 17.
You didn't use 12.
No.
We used 10 and 12 already, yeah?
16 times 11. No, wait. Okay, no.
Never.
So what does this mean about this problem, guys?
No solution.
Can't be solved.
We can't find one to break it up. So maybe the original problem could not be factored to start. We always have to think about that. Since nothing,
Wow.
we want to think about it.
I'm sad.
Since nothing actually works here, maybe it can't be factored.
How is it?
We also, keep in mind, we didn't list this one. We should still list this one even though it's not really going to work, right? But let's go through our numbers. We tried 1, we tried 2, we tried 3, 4. We tried 5, we tried 6. We said 7 doesn't work. How do we know 7 doesn't work? So 7 going to 120 really?
No.
How do we know that? Doesn't 7 go into 140?
That's gonna be,
Yeah, because it's 14.
So if it's 20 less, it's not going to work because 7 is not a multiple of 20.
the next one will be like 7 and,
We said 8. It didn't work. What about 9? Did anybody try 9?
Oh my
Yeah,
god.
let's try 9.
Did that work?
No.
And then when we got to 10, we're back. We already used 10. And then once we get to another factor or another pair, it means we can't go any further. So this one, we can't factor this one. But you see why we can't factor it now at least. Okay? All this work and we can't factor it. Let's try last one that we can factor. The bell's going to ring in a minute or two. Let's just keep going.
1 minute.
Okay, let's try one more. That one is unfactorable. I want to show you though, guys, that not everything is factorable. So you can't factor, we're going to use the quadratic formula at the end of the year. Or toward, not the end of the year. In about a week or two, we're going to You're not going to have a concept quiz on this. This is another side note. We're going to use this like next week or 2 weeks from now. So we're just learning it to understand.
Name was like,
Let's try.
oh god, don't remind me of the pain and suffering, misery.
Let's try this one now. 12x squared plus 11x plus 2. Notice I already have the factors. I made it. What is AC? Quick.
24.
What is B?
11.
Okay, we start by listing those right away.
Alright.
AC is 24 because it's 12 by 2. Go.
3 and 8.
3 and 8. Do I stop?
No.
Yeah,
I'm done.
No, no. 4
No, we're
We
done.
found the answer.
3 and 8 is 11, man.
I still want to do some practice.
Now, we can keep factoring. We can keep going, right? But it's no use to continue this process because we found our answer. So now let's go to the next step. 12x squared plus 8x plus 3x plus 2.
Could you find factors on this?
We just did.
Yeah, break it up.
There are programs that can, but I want you to be able to do it this way.
Yeah, break it up. Yeah, break it up.
When you can, yes.
Yeah, break it up.
Now, let's break this down. Split it down the middle. What is the greatest common factor of 12 and 8?
4.
And then we take out an x also. We're left with 3x plus 2. And take a look on the right side. What is the number? What is this value already? 3x plus 2, 3x plus 2. So can I factor anything out of that? But I can always factor what number out of everything? 1. So please put a plus 1 because it will come into play. 3x plus 2. Because if you remember, how are we getting our factors? We're using this value and we're using this value. So one of our factors is 4x plus 1 and the other one is 3x plus 2.
Yeah.
Hey, this was an easier one. This was a little bit easier than the last one.
Where do you get?
Oh, okay.
The 4x here,
Yeah,
the 1 comes here. Now, real quick, let's think about this. How am I making up these problems? I'm picking the factors ahead of time and then multiplying them out for you. So what I want you to do tonight, I want you to do homework problems 3 and 4 for concept 7 already, which is what you're going to be assessed on Tuesday.
So are we done with that?
Okay.
Is that
For AC method, I want you to practice 2 of them over the weekend. So you got 2 homework problems for your worksheet, and I'm going to write down 2 for you to practice right now.
Can you go back?
Yes.
So you're gonna give it to us?
You know what, Eddie, let me go back in a second. Let me put the homework up first, okay?
You're gonna give it to us so we can do it on our own, like on our own worksheet?
And you know what I'm going to do? I'm going to give you the answer and then the quadratic, so you can check that you got the right answer.
Oh.
So this one is going to be, you're going to have to factor 12x squared plus 2x minus 2. That's going to be the first one you're going to have to factor. The second, and again, I'm giving you the answer. This is the answer right here. So when you factor this, check that you got to that answer.
Oh, that's the question right there.
Okay, so here's the question right here. Above is the answer. The second one, I'll give you the answer. We'll use 5x minus 3 and 2x plus 4. So this one will be 10x squared plus 14x minus 12. Again, you're already given the answer here, and you're already given the question. Check exactly. Go through all your work, and this is a practice for you guys.
Good afternoon.
Okay? I'm going to stop recording now for
Please stop
announcements.
what you were doing, let me have her.